Well, welcome back, everybody. Today we're being trained on the equipment we need for next week. I hope you're as excited as I am to come back. It'll be nice to see many of you next week. So what we're going to continue with today is yesterday's lesson, which is compound or combined inequalities. You have two inequalities in the same problem. This one is what we did yesterday. The only difference is we have negatives, which just makes it a little bit more difficult. If you need to make a little graph to help you, you don't have to graph your answer, but just make sure that you put the numbers in the correct orientation. Otherwise, you're going to get it wrong. Like obviously -8 is to the left. So I'm looking for the numbers that are smaller than -3. That would be everything. So from here on over, so I'll just put like a yes in these two sections, and everything from -8 on over to the left, that would be a yes here. So this section is not part of the first. This is these bottom two are not part of the second. So for an and, this should have a D here. Wish I could spell. So for an and problem, it has to make both true. So it's the numbers that satisfy both. The numbers that satisfy both would be just the ones from -8 to the left of -8. So my final answer is just A is less than -8. Now, that's what we did yesterday. Here's what the point is. You're not going to start with problems like this. These are already finished, but a lot of people think that because I solve and do a couple steps to get to here, I'm finished. So for example, number 2, same directions I want to solve. You can pause if you need to write these, but this is easy to solve. On the one on the left, I will just subtract 7, divide by 3. The one on the right, just make sure you're careful when you divide by the negative. We have to flip the direction, and x is greater than -4. Now, this is what I said. Because you did some work to get here, people think that, okay, that's my answer. That's when the thinking just starts. So now this is what we talked about yesterday. Well, what would be my answer if these are the values that work? Again, you can make your little chart if you need to. This is not a must. If you get it wrong and you don't do this, you really should. So the top one I'll put, the left one I'll put on the top. So smaller than 5 would be these two sections. Larger than -4 would be these sections. It's an or, which means it has to make at least one section true. Every number is covered by one of them, and everything from here to the left is covered by this one. Everything from here to the right is covered by this one. So my final answer is all real numbers. You have to show all this work, but my final answer is not the or statement. Remember, we never leave an answer with an or. This next one, put a star next to this. Give you a second to write this. You can pause if you need to. This doesn't have the word and or the word or. This is the idea of between that we talked about yesterday. Between is always an and concept. So what this means is I have two statements separated by the word and. It's going to be -3 is less than 2 minus 2x. So just like stop here. And then the second part starts here and does everything to the right. That would be 2 minus 2x is less than or equal to 1. So then I solve each of these, subtract 2, divide by -2. Don't forget to reverse the direction. I think it's difficult to think about these combined inequalities if you don't have the variable first. This one has a less than or equal to. Just be careful. You don't have to have the same symbol on both parts of the original statement. So I can subtract 2, subtract 2. I'm trying to do two things at once here. Subtract 2, divide by -2, flip the direction. But this is what a lot of people do, and they ignore the word. The word is just as important as the numbers here, because if it was an or, it would change the meaning. So what numbers? Well, let's make our little chart here. So 5, so 1/2 is smaller, so 5/2 would be here. I want the numbers that are smaller than 5/2. that would be these two sections, and bigger than a half, that would be these sections. So since it's got to be both, that would be the middle section. My final answer here is 1/2 is less than or equal to x, which is less than 5/2. You never write a final answer using the word and. All right, let's do this same problem another way. Don't love to do everything more than one way, but some of you might be even thinking this. Let me make another page here. So I'm going to write the problem. Most of you will probably like this second method better. Instead of having to write the two statements, we just know it's an and, but you can work on both sides, and this is perfectly fine. So what I'm saying is, as long as you show this work, don't do this in your head. So I can subtract 2 on both sides, on the left of the middle and on the right of the middle. So I get -5 is less than -2x is less than or equal to -1. Divide everything by -2. Again, just be careful when you divide by a negative. So this would be 5/2. I have to flip this, and this is the same thing, except it's going from large to small. I like usually writing it from small to large. So I would have +1/2 is less than or equal to x, which is less than 5/2. But the either one is perfectly fine. So this method is great, or this method is great too. Now, just because you get to here, though, don't stop, because it is possible to have an answer here that doesn't work, like it doesn't make sense, and then you would get no solution. So always make sure you analyze, does this even make sense? Are there numbers that are between 1/2 and 5/2? Absolutely. But if you had something where you couldn't have numbers between the two boundaries, then it would be no solution. Go ahead, pause the tape, and try. Actually, just try number 4. Go ahead and do number 4. All right, the answer for that one, let's move this out of the way. So this is an or. That's, again, really, really important. I'll combine my variables. I'll move I'll subtract 3a, but I'm going to write that as a is less than -1. Or over here, I will add 2a, -12. I can't write today. Erase that. So -12 is greater than 4a. Divide everything by 4. Doesn't switch it. But my symbol is on the wrong side, so I have a is less than -3. Well, what numbers would work there? Again, you can make your little chart if you need to. Put -3, -1. I want the numbers that are smaller than -1. That would be these sections. Smaller than -3 would be here. But it's an or. An or only has to make at least one of them true. So my final answer here, my only answer, is the place that has at least one yes, which would be that. All right, and finally, this will pause. Go ahead and solve that. All right. So I'm assuming most of you, now again, you can write you can write this and then the word and then you can write this, and that's great. Most of you are probably just going to add 3 to both sides, to all the sides. So I'm going to add 3 here, add 3 here, and add 3 here. Gives me x is less than -2x, which is less than x minus 6. Now I do need to put my x's in the middle. So I'm going to subtract x here. So I have to subtract x everywhere. So if I do that, I get 0 is less than -3x, which is less than -6. Divide everything by -3. Again, as long as I do it in all three parts, this is fine. Again, I'm dividing by a negative, so I get 0 is greater than x, which is greater than 2. Many people circle this as their answer, but you have to analyze this. This is what I just said 5 minutes ago. What numbers are between? Like, well, this means that 0 is greater than a number, and that number is greater than 2. So if you think, like a lot of people think, well, 1 would work. Well, is 0 greater than 1? No. Is 1 greater than 2? No. There's nothing that's going to work here. This is no solution. So there are no numbers that 0 is greater than that number, and that number is greater than 2. So again, my final answer here would be no solution. The assignment is in Canvas. I will see you all live tomorrow.